This paper is entitled Practical Use of Procedural Automation in the Nuclear Industry. Be presented by Chris Corleoros. Say that 3 times fast. Who works for Novatech. Novatech Process Solutions, he's the D3 product manager. Chris has 13 years of process control experience, including 10 years of application work at various facilities, majority of the time spent at the Savannah River Site Nuclear Reservation in Aiken, South Carolina. Chris has served as a technical lead for the automated procedure development in the tritium extraction facility. Seems to me I've heard about that somewhere. He's been involved in a broad range of process control related projects with a focus on automation, alarm management, HMI development, and process analytics. He is currently serving as a product manager for the Novatech D3 distributed control system, and Chris is also one of our co-conspirators on the 106 committee. One of those stealth members that calls in most of the time. But Chris?
Okay, this is going to be pretty much a continuation from Laura's presentation. I worked on the same project. Laura was the overall lead, and I was more of the technical guy. So this presentation is going to focus on more of the technical aspects, some of the challenges that we saw to implement procedural automation. It'll give you a lot more detail and hopefully clear things up. So this presentation will go over a vision for automation of the new plant. We'll talk about the procedural automation methodology that we adopted and lessons learned. And this is actually a picture of the tritium extraction facility. Next to it, there's another facility as well, the RTF facility that recycles tritium from nuclear warheads. And a lot of these processes here were modeled from the existing facility. The difference between the two is this facility actually creates new tritium, whereas the other facility sort of recycled tritium that was there. So this is our tritium generation plant for the nation. Just to give you a little site background, the Savannah River site is a nuclear weapons processing facility just south of Aiken, South Carolina. It borders South Carolina and Georgia. It's a large facility. It's like 320 square miles. It employs about 10,000 people, and there's a lot of plants and little facilities peppered throughout. That site does a lot of plutonium, uranium, and tritium processing. Tritium, just to give you a little background on that, is a radioactive isotope of hydrogen. It's used as a nuclear accelerant. It has a short half-life, 12 years, so that's why these two facilities are important to keep our stockpile. So this is my rhetorical joke type question. How important is it to follow procedures, especially at a nuclear facility? And yes, the answer is it's very important. Procedures are very instilled in the operator's mind. As Laura said before, the operators they have to know everything that's going on in the system. They're the ones that are ultimately responsible, and they understand procedures. That's the terms that they think in because that's what they have to follow and document and do. So with the new automation product that we did, we knew we wanted to do something with procedures and keep the level of automation, because we had that luxury to come up with something new, keep that level of automation tailored to what a procedure is. So we conducted a system review. We had an existing facility to get a baseline and look at the experiences that we had. And we kind of broke it up into 2 areas, procedures and interface. The procedures at the existing facility were done in Microsoft Word. Sometimes they were in the minds of operations. They were printed for execution. The executed papers were sent for records. And they had a record keeping where they were supposed to keep the paper copies for 20 years. So as you can imagine, that a lot of paperwork has kept track of. So for us, we wanted to do something in the electronic field to sort of automate that process as well and introduce something new where we can electronically keep these records. From an interface standpoint, and this is what really initially drove procedural automation for us, it was a combination of paper, HMI, and DCS software. So operators would go to a file cabinet, pull out procedures, sit it next to the DCS, and start executing. Some automation, we had sequential automations in the control software that we've automated sort of over time, those repetitive tasks that were more efficient to do with automation. And we had some processes that had utilized S88 batch type of recipes. We found that this was a little confusing to the operators, mainly when they had to work with the stepwise style printed SOP procedures, and they had to work with the sequential style unit-based control equipment modules, and they had the batch style as well, where we had different interfaces. We had, little things peppered throughout the process graphics. We didn't have really one place where we can view everything. And the most important part is the level of detail that was presented to the operator. Some of the information, because engineers like to put a lot of detail, was too detailed, and just like over-alarming, we threw a lot of messages at him. And other times where we wanted to limit that because we knew it was causing problems, it was not detailed enough. So when something went wrong, automation was more seen as a black box. So we wanted to do something about it, and once again, put overall automation in procedural terms that they understand. So we started at the beginning, started at looking what our procedures were. Fortunately, the Savannah River site had really good paper procedures. The Department of Energy has an overall standard for procedures. The SRS facility has its own set of standards that fulfill the overall standards. And pretty much all our procedures were in pretty good shape. We looked through hundreds of procedures and we tried to figure out, ultimately what makes a procedure. So we found that the performance steps, the action verbs, kind of narrowed down to specific patterns. Perform this action on this resource to get this result. Perform this action until this condition is met. If this condition, then this action, and so on and so forth. And logic-wise, we found that it wasn't complicated logic in the procedure, that for the most part it was just a series of if, then, and else statements. So in utilizing this, we wanted to look at, once again, going electronically. And it didn't make sense for us just to take something from Microsoft Word and start from there if we wanted to make it an electronic procedure package. So we thought about it and said that the procedure steps then can be converted into actions, transitions, go-tos, messages, and queries, and these areas can be implemented graphically. So that was sort of the goal that we wanted to do, have our procedures graphically, but still let the operators and operations in general keep kind of what they're used to. And I'll go through that process. Some additional areas of improvements. We wanted the procedures to be readily available and that the current procedure is the latest revision. We wanted to reduce the amount of paperwork, standardize on format, and preserve the knowledge of operations. This is kind of it's sort of buzzwords that a lot of people throw around, preserve the knowledge of operations. And as Laura kind of alluded to before, written down procedures don't necessarily capture knowledge. Because sometimes the procedures are written where things like, slowly heat up this or other statements that require some sort of process knowledge beforehand. But because we wanted to go electronic, we wanted to be able to quantify those things and really preserve the knowledge of operations. Sort of like the brownie. I want to follow the recipe exactly every single time and get, the same consistent brownie throughout that I want. From an interface standpoint, we wanted a procedure-oriented interface that was common between the systems. We wanted a dedicated window with audible alerts and something uniform and consistent throughout the systems. This was kind of important to us because our automation was sort of peppered throughout and we were looking at multiple interfaces. We really envisioned the operator console as something where they have one screen for HMI and a window into their process, the other screen for alarms, and then a final screen just for procedures, because procedures were really an integral part of the system. And I kind of liken the automation to sort of like alarming. You could have alarms. You can go through all your process graphics to get alarms, but an alarm summary is really nice because then I can filter and sort and look at my priorities and really get to where I need to be. It's kind of the same with procedures as well, the way we saw it. Having one dedicated window where we can see everything that's going on and answer messages and get it was something that we saw beneficial. Looking at the operator interface, we kind of thought, okay, conceptually, what should an operator interface consist of? And we went and polled a lot of operators, and Laura kind of showed you a different example of it. But basically, we wanted a spot for a list of running procedures. When we click on that procedures, we wanted to see detail in a language that's consistent with procedural style. We wanted to be able to add and remove procedures, interact with the procedures, issue commands to the procedures, and switch between the different systems and units. One thing is we didn't want to introduce something totally new, and we didn't want to hide information either, so we took a simplistic approach to viewing the procedures. And this is kind of overall conceptually what we came up with. Now, the solution in general, in taking the flow chart and looking at the interface and putting it kind of all together, this was the architecture that we sort of imagined and we based everything off of. So in the center is our flow chart. That's the heart of where everything happens. That's where the procedure gets written. That's where automation is put in. That's where formatting, just everything is one central place where all that takes place, and it's a flow chart. So from the flow chart, because operators necessarily didn't want something new to flow chart, we wanted to be able to export to a written procedure, a PDF type document. So we came up with a conversion tool to go to PDF. Because the flow chart, once again, it lends itself well to treating objects as little database type objects and to be able to embed multiple properties in flowchart window, we were able to come up with a way of embedding automation code and running it inside a procedure-based HMI. The record from the procedure-based HMI, when we run it, we wanted a PDF too, a secure record. So once again, introduce something that operators know, procedures. So the HMI record looked like the procedure that was exported from the flowchart. And this was kind of neat because it was presented in a way where it would have been just like if they would have, went to the file cabinet and looked up whatever procedure happened at what time. It just looked like a procedure that was kind of filled out, even though it happened electronically. And it was in a format, I didn't have to sift through DCS log files or come up with special reports. It was in the format that they were used to. And another kind of got you was they had a lot of procedures, so perhaps there's a way to come up with a tool to reverse engineer and cut and paste text back into the flowchart. We kind of worked on that a little bit. The thing with the procedures are, starting with a flowchart, the first question is how do I envision what a procedure should be? Because there are different styles out there. There's the sequential or state-based style, and then there's the stepwise style of a normal procedure. We found that state transition diagrams didn't really lend itself well to visualizing and getting to the step level that we needed to get at. So we kind of, because we had worked on some S88 projects, kind of borrowed the methodology and the overall structure of the procedures because, it lended itself well to continuous operations too. I think I heard earlier that a joke, what is a continuous operation? It's just a batch operation, running for a long period of time. So it's something that sort of made sense. So for here, our control or master recipe kind of translated to what our main procedure, what this is going to be about. Our unit procedure kind of translated to, these are like the subsections. And then for the operations, which was a group of phases in S88 world, kind of translated down to the series of the procedure steps. And here we had all the logic that we needed to accomplish procedures. Once again, SRS, a lot of good standards, and we needed to conform to, and that exported copy out needed to conform to those standards. So just kind of looking at it, the purpose, the scope, the prerequisite actions, all those steps, things that were text were easy, things that were just simple things were easy. But the performance actually was the toughest to implement. And that was because of the way they chose to execute their procedure. Basically, it was how they chose to group things and what they were used to before. So I have a procedure called furnace operation. And the furnace operation could have a heat up, a process, a cool down, whatever. They didn't want to always have these procedures open all the time. They wanted to go to what they wanted, pick the section they wanted to perform it, and then that procedure is closed. Sometimes the furnace, could operate for years straight. So it wasn't, they didn't want to have something open all the time if it was not going to be a common thing that they perform. So we had to build things to help accommodate that. Once again, just to kind of go back to the S88 and kind of what we borrowed and look at the numbering, how it formed over. So if I have a furnace operation, which is my section 5 performance, let's say I have 3 sections, 5.1, 5.2, 5.3 in my operational. And then the steps happen, after that. It sort of had a drilling down to get to the different sections from the flow chart. So transitioning to the flow charts, here I just have a couple steps. If a domestic water supply will be used to fill the system, then connect the supply hose and record the valve numbers. And here is how we illustrate it on the right-hand side. So here we could see, it's just the if, then, do this, else. And the reason I kind of showed this was it was really easy for us to visualize then what a procedure does. And having it in a flowchart format was really nice because they could see then, where does my logic end? Where is my procedure taking me? Whereas if I had 100 steps in Word, sometimes it was really hard to discern where my logic was going. Well, in a flowchart, I get my start and my stop, and I get to see where everything goes. So the transition to the flowchart was actually a lot easier than I thought it would be. Once again, with the actions and embedding dynamic properties and treating these actions like a mini database, we had things for like verb and object. They had different ways they wrote their steps, and we kind of split it up so that they could enforce that standard way of doing those steps. So things like ensure this valve is open is a common way of saying it. It's not open this valve or whatever. So we wanted to come up with a way to enforce the standard way of writing things. We had things for formatting so that we didn't want the procedure writers to worry about formatting. So ways of embedding checkboxes, initials, record values. And then the neatest thing was the DCS functions. Because it's a one-to-one, we could associate every step with a DCS function. What we did here was we built a library of common DCS functions the operators performed. And basically here in the shapes, we reference then that function and just define what the inputs should be to it. And this was kind of nice because then in the flowchart, the procedure, the automation process guy didn't really have to concern himself with a lot of the code. And we had a lot of people that were probably not inclined to write DCS code, sort of like S88 did as well. So it was kind of neat how we were able to do it. And we thought that this would be the hardest part, taking a procedure, kicking out automation code, but it really wasn't. This was the easiest part. So once again, information in these blocks are used to automatically create the PDF procedure, operator interface input, and DCS code automatically. Here's an example of sort of what the PDF procedure looks like. And it's hard to read, but the things to point out are, they didn't have to worry about headers, footers, page numbering, notes, tables, record entries, or anything like that. From this flowchart, we got a really nice formatted procedure that was what they were used to. Also, from the flowchart, because once again we could embed the commands, we were able to kick out DCS code. And transitioning to the operator interface, we wanted a way to take this procedure and, okay, what do we make it look like, from an operator's point of view? Because the big benefit with the procedure automation, once again, is getting the right information to the operator in a language which they were used to. So we chose on a tree view type because it took the tiers and the hierarchy that the procedures had. It was a clean way of doing it. We were able to do fancy stuff like put tables, and we really made the operator interface then look kind of just like a procedure. Once again, in a language that they were used to. Executing the procedure was really where we saw a lot of benefit, mainly because we clearly showed in this interface kind of where we're at, and here this is a bold highlighted green, where we've been, this is kind of grayed out with timestamps, and where we're going. So it was something where if I didn't know where my procedure was at, I could sit down on the system and I could follow that, where I've been, where I'm at, and kind of where I'm going. Once again, not to hide anything from the operator, but get them the right information whenever they need it. Some of the benefits that we saw was, number one, it was procedure-oriented. It really strengthened the operator interaction with automation. No longer it was a black box to them. It was something that they could read. We had a library of approved procedures organized by system. I'll talk about the execution here in a little bit, but we had to come up with ways of how to execute the procedure. And also, once again, to create an electronic record, an executed electronic record. And here's an example of the record. Once again, from the PDF, it looks just like the procedure did, with timestamps, with comments, with DCS results. That was sort of the record of execution. All in all, this was a team effort for procedural automation. It really caused the engineers, design engineers, they would define the requirements for the procedures. The procedure writer then would populate the flowchart from the requirements, and the programmer would fill in the parameters then required for automatic code generation, and nothing was lost. We like to say, really, everyone was on the same page because they worked from the same page. Now, just going into some of the lessons learned, procedures needed methods of execution. And we kind of split it up into 3 methods of execution. The first method is that the computer steps through the automated procedure. And this for us was, no operator interaction was needed to advance to the next step. It was something that the DCS did sequential. For us, we had, and I'll explain this in a little bit, what we call these equipment groups or equipment modules. Really, they're unit state-based control modules. They were executed in this method, that I just wanted to have something continuously looping. The second method of operating was that the operator steps through the automated procedure. So the operator then, an operator command was required to advance to the next step. And this is pretty much how they ran all their SOPs or stepwise procedures. They were all executed in this method. So the operator, they would have their window of their automation. They would look at their DCS screen, and if it said here, open this valve, they would look at the valve, hit the command button, watch it open, watch it registered on the procedural window. So it was a way to kind of strengthen and just kind of make sure that the operator was doing what they need to do it, step through sort of in a semi-automated way. And last, we had where the operator steps through a non-automated procedure. This is a procedure executed with no DCS interaction. This was more basically used as a training tool. So without DCS interaction, they can kind of run through the procedures and look at the logic. It was also a way for them to fall back in case something went wrong. It gave them some peace of mind. So that if I'm running an automated procedure, let's say something happens, I lose view or lose control, it's something where they can right away take that automated procedure, go to a manual type mode, and execute things manually. Or vice versa, they could print it out to PDF with everything that they've done is all filled in, and then everything else they could execute in and do things manually. So it was sort of the fallback method. Another lessons learned is we really needed a way for procedure allocation. And this was something that grew more important. So we needed a clear way to show who had control of the equipment. Also, we needed a clear way for the operator to gain control of the process without disrupting the procedure. And this was done because, once again, the operator has the final say on their system, not necessarily the procedure or the automation. So they needed a way to go in and take it from the procedure. So the way we did it was we introduced the paradigm that the procedures and operators were both seen as users of the equipment. So we had a little button on the process graphics where it just told us the status of who had the system, the ownership button. If it was available and a procedure was set to run, the procedure would automatically take ownership of the equipment, and the procedure had then, the free rein to do what it needed to do. The procedure was written in a way where that every step it always checked that ownership. And vice versa, if an operator needed them to take that procedure, they would click and take that unit, and then it would be allocated to whatever console they were running from. And this was also expanded further that, by getting a procedure and looking at it as a user, we also had a way to control other operators from stepping over other operators' toes. So procedure allocation is really important because you want to show who has ownership of the equipment at the time. Another lessons learned, and this was more for sequential, we still wanted to keep our unit-based methodologies because they're really good for automating a lot of continuous things. And we wanted to keep our stepwise automation because it's the overall control and what's going on. So we needed a way to capture the information for our equipment groups. And these became continuously running procedures. And once again, state transition methodology. So here, the way we've done it was we still kept the same layout. In our unit procedure, it just kind of looped around. So our main procedure was what processing area do you have? Here, it's the then states that the processing equipment could be in, and then logic for the states would be embedded here where we could do whatever logic we did. So it was just a way that, for the continuous running procedures, we just needed procedures to kind of loop all the time and handle those common actions. And we really did it because it's one thing to show everything stepwise. That's an easy way of doing it. But equipment groups or state transition methodologies, they could go wrong too. Something could happen where it could get hung up. So once again, it's about translating that logic into something that they could understand and troubleshoot. Another lesson learned was it was difficult to account for every procedural scenario. So this step, like if I'm heating something up, And I had a statement that says, if at any time during these steps the temperature goes greater than a certain value, do this, and then, oh, come back. So it's a way to handle exception or corrective actions within your procedures. So this was a little bit more complicated because in state transition world, for the continuous procedures, we could do this really easy because that logic was embedded in. But for the sequential, we had to come up with a different way of doing it and handling it. Also, we needed to include things for DCS hold and exit. And this was important because procedures writers don't necessarily account for what the DCS does and what state does it need to be in. So we really thought it was important to include what a hold and an exit statements were doing within the procedures. We needed the ability to embed native DCS code in the procedures. Some of the things were more efficient just to do it out, especially when we didn't have a library automatically done for it. And also, alarm management and procedures go hand in hand, that if you're running everything from the procedure, and here we utilized a dynamic alarm management methodology where we put a state to our pieces of equipment, and then we had our alarms change based on, either recategorize or, values were put in based on the state that was changed. And it was really easy. For the overall picture, we wanted to embed that within our procedure. And they really go hand in hand. You can't forget about alarm management. It's not something separate. It's all part of the procedures. And that's all I have. Any questions?